All right, we're going to look at some problems from section 6.3 in our textbook. This is where we have introduced logarithms. And we've got a number of different problems here. The first one asking us to rewrite in exponential form. And remember, we were introduced to logs. We said the log base b of x is equal to y if and only if b to the y is equal to x. So we're going to use that format to be able to go back and forth between exponentials and logs. So here, to rewrite it as an exponential, 15, our base raised to the second power, is equal to 225, and we know 15 squared is 225. And here the same thing, 17 raised to the negative 11 is equal to x. We don't really need to compute that, we're just rewriting it. So here, sometimes it's a little more difficult going from the logarithmic to the, or the exponential to logarithmic. But one of the key things is, remember, that's your base. So we have the log base 11.6 of b is equal to a. Right? And if we were to go back and rewrite it as we did with the logs, 11.6 to the a is equal to b. And then same thing here, we'd have the log base 4, that's our base, of 16 is equal to 2. Right? And if we were going to go back, 4 squared is 16. Okay, so we have some evaluating, and it may help to write this as equals to x. So we have 4, we're going to write it as an exponential, raised to the x is equal to 1/4. Lots of different strategies. I think the easiest thing is to get both bases to be alike, and once they are, then we can set our exponents equal to each other. So we're going to keep it this side in base 4. 1/4 is the same as 4 to the negative 1. And now that our bases are alike, we can set the exponents equal to each other, and x has to equal negative 1. Doing the same thing over here, again, set it equal to x. 7 raised to the x is equal to 1/343. And again, using your table of powers if you want. We're going to first rewrite this as 343 to the negative 1. And then I know 343 is 7 cubed. So 7 cubed to the negative 1. Power raised to a power, we're going to multiply. So 7 to the x equals 7 to the negative 3. Our bases are alike. X has to equal negative 3. Okay, a few more here. One more in terms of our or evaluating rather. So again, I'm going to set it equal to x. So I have 16 raised to the x equals 1/4. So this is a situation that I'm actually going to have to rewrite both sides. So I can see that 16 and 1/4 can both be written in base 4. 16 is 4 squared raised to the x. And 1/4 is 4 to the negative 1. Power raised to a power, we're going to multiply. So 4 to the 2x equals 4 to the negative 1. Now that I have our bases alike, we can set our exponents equal to each other. And x equals negative 1/2. Okay, this one's a little more complicated. We don't really see many of these in our text. But we're going to use these properties and value, or use log properties rather, and these values to try to evaluate this. Well, the first thing that I notice is that I have a division. So I am going to use the property to subtraction. So log base 3 of 5 minus the log base 3 of 8. And now how do I get to 5 and 8 using these? Well, for me, 5 is the same as 10 over 2, and 8 is the same as 2 cubed. Now I don't have a 2, but I do have 4. And one of our properties is that this can be written log base 3 of 2 squared, which is the same as 2 times the log base 3 of 2. So using that idea, I'm going to write this as log base 3 of 10 over 2 minus the log base 3 of 2 cubed. So that's the log base 3 of 10. Minus the log base 3 of 2, right, using our quotient, minus, and now over here, I'm going to actually adjust this a little bit, and instead of saying 2 cubed, I'm going to say 4 to the 3/2, right? Square root of 4 is 2, and then 2 cubed, and again there I'm using 4. So minus, see in parentheses, the log base 3 of 4 to the 3/2. And so for 2, I'm going to change that to 4 to the 1/2. And now using our power rule, we have 3/2, the log base 3 of 4. And then over here, using our power rule, minus the 1/2 log base 3 of 4. 3/2 log base 3 of 4. So now we're using our values that are given, our 10s and 4s. So now I just substitute. So I have 2.1 minus 1/2, 1.3 minus 3/2 times 1.3. And all of that is going to equal negative 1/2. Okay, lastly, finding the inverse. Remember, we switch x and y and solve for y. So I'm going to write x equals the log base 2 of y to the 4th minus 3. We know that the inverse is going to be an exponential function. First thing we're going to do is add 3 to both sides. So now rewriting it as an exponential, 2 raised to the x plus 3 equals y to the 4th. I'm going to raise both sides to the 1/4 power. And so this is going to be y inverse is equal to 2 raised to the x plus 3 raised to the 1/4. And now here we have an exponential function, so we know our inverse will be a logarithm. So again, I'll switch the x and y. We're going to solve for y. So I'll multiply both sides by negative 2. Subtract 7. And now I'm going to take the log base 6 of both sides. Squeeze that in. Let me rewrite that a little bit so it's a little clearer. Well, we know that equals y, and now we're on our last step, so that's going to be y. So I'm going to write y inverse equals the log base 6 of negative 2x minus 7. All right, hope that all helps, and we'll see you soon.